Now comes the question 8. Over here, the diagram is showing this curve y is equals to x cube multiplied by ln x for the positive values of x. And the minimum point is denoted by letter m and it's marked in the diagram as well. And we are asked to find the exact coordinates of m. Exact coordinates means we don't need to give answers in format of decimals. It could be in the format of surds. It could be in the format of fractions. Something which is not in decimals represents some exact coordinates, all right, or an exact value. So now how can we find out the coordinates of minimum point? Now, if you think about your AS level concepts, it makes sense to use calculus over here. We can find out what's the gradient function, that is what's dy by dx of this, equate that to 0 and find out the value of x when that happens. And once we get the x values, substitute it back into this to get y value. This logic is what we are going to implement over here. And again, because two functions are multiplied, we can use this product rule when we have to take the derivative of the two things that are multiplied. It's derivative of first thing keeping the second thing as it is, then second derivative keeping the first thing as it is. That's the rule that we are going to implement over here as well to find dy dx. So let me just find dy dx over here itself. So my dy dx, what's the differentiation of x cubed? It's 3x squared, keeping the second term as it is, that is ln x. Plus, what's the differentiation of the second term? It's 1 by x. I'll keep the second term as it is, that is x cubed. If I simplify this becomes 3x squared ln x plus x squared. If I cut this with this, I'm left with 2. And now if I take x squared as a common term, then I'm left with 3 ln x plus 1. So that's my dy dx. Now I know that dy dx must be equal to 0 for the turning point. So I'm saying that x squared times 3 ln x plus 1 is equal to 0. Now there are two solutions from this. What are the two solutions? Either this implements either x is equals to x squared equal to 0 or 3 ln x plus 1 is equal to 0, because both of them are factors. So x squared is also equal to 0 or this is also equal to 0. Okay? So if you solve this over here, you get x equal to 0, which is obviously the stationary point that you are getting over here, which is the maxima. But that's not something that we want. So we get rid of this and solve this and make x the subject over here. So over here, it will be 3 ln x equals to negative 1. ln x is equals to negative 1 by 3. And now because we want to get rid of this ln, we can introduce the power on both the sides of the base of this logarithmic term, because we know that base to the power of log of base of x is nothing but equal to x. So what is the base of ln? It's log to the base of e. So we can have e on both the sides. And therefore, the x coordinate is e to the power of negative 1 by 3. Because on the left side, this becomes x. On the right side, it becomes e to the power of negative 1 by 3. So that's the x value of this m. What is the y value of this m? So for that, we have to substitute it into this equation. So y is equals to e to the power of negative 1 by 3 times 3 is negative 1 times ln of e to the power of negative 1 by 3. So I can write the same thing as y is equals to e to the power of negative 1 can be written as 1 by e. Then with the help of the power rule of logarithms, I can bring that minus 1 by 3 out, like into the bottom part that is in front of ln. This is negative 1 by 3 ln e, and ln is nothing but 1. You can check that out in the calc. The final value of y that we are getting from this is minus 1 over 3. So what are the final x and y coordinates of m? This implements that m is having the coordinates of 1 e power of 3. That's your x. I'm just writing it in the fraction format. And this will be minus 1 over 3. So that will be the solution of the first part of question 8. What did we do? We used the product rule first of all to differentiate this. equated that to 0 because of the stationary point, and then solved for x. Over here, we are using the logarithmic rules and the exponential rules to get to the values of x. Once we get the values of x, we are putting it into this equation and then just simplifying it over here. So this is your x, that's your y. I'm just converting both of them into the fraction format, and that will be the answer of coordinates of n. I hope that's clear to all of you. And now it's time to move ahead and let's see what is the part B holding for us. Okay, so let me scroll down. I guess it must be about checking if it's minimum or maximum. Oh, okay, never mind. They're asking us to find the exact area of the shaded region bounded by the curve and the x-axis and the line y, I mean x equals to half. So I don't think so M has any kind of task over here. So I guess we can get rid of that as well. So this is bounded by x, this is bounded by curve, and x equals to half. So that's the shaded area. Basically, that's what we are asked to find. So how can we do it? We can integrate this curve from half to that value of x. How will you find that value of x? That's when y is equal to 0. So 0 is equals to x cube dot ln x. So if you solve this, x cube is equal to 0 or ln x equal to 0. Obviously, this is not the part because that's 0 and that's not something we want. Over here, if you do e power on both the sides, so this becomes x is equals to e power of 0, and therefore x will be equal to 1, right? I'm again implementing the same rule of the power. To get rid of this, this will be equal to x, and on the right side it will be e power of 0, and anything to the power of 0 is equal to 1. So that's 1. So I need to integrate this curve from half to 1, and once I get the answer will come out to be negative. So I just need to keep those things in mind before I find out that area. So if you just scroll down, and yeah, we have to find the exact area. We cannot give answers in decimals. So, and the equation is y is equals to x cube into ln x. Y is equals to x cube into ln x. All right. So the formula of the shaded region, therefore, shaded area is what? It's integration of x cube dot ln x dx. Now, when this kind of things appear, when two things are multiplied for the integration, we use integration by parts. So there are the rule that you are going to use is ILATE rule, where we can see that logarithmic terms come first, algebraic terms comes later. So ln becomes your u and x cube becomes your v. So you can say that integration of uv is equals to u integration of v minus whole integration of u dash integration of v. That's the formula when two things are multiplied with the help of integration by parts, where we are considering how do we decide what's u, what's v. The quick way of is to use this kind of thing. So this is a logarithmic term, this is algebraic term. Whichever comes first, that's your u. Whichever comes later, that's your v. And therefore, u over here is ln x. V over here is x cube. Now, what's your u dash? Because we need to find what's u dash. That's going to be 1 by x. What's the integration of v? It's x power of 4 divided by 4. That's enough. You don't need to bring integration constant over here. That would be getting rid of because we are also having this kind of limits that is from half to 1. So we don't need the integration constant in any ways. So now if we substitute this formula into this integration by parts, this becomes integration of uv, that is nothing but x cube, or I can say ln x multiplied by x cube dot dx is equals to u integration of v, u integration of v. That is 1 by 4, or I can say x power of 4 by 4 multiplied by ln x. Now see, how do I know that I have to find u dash and integration of v? Because of the practice. I know that in this formula I need what is u dash. I also need to know what is integration of v. So because of that, I have done that. Now the first part is done. U integration in v is done. U into integration of v is done. Now I need to take away integration from half to 1. This is also from half to 1. And over here I have to integrate u dash into integration of v. That becomes 1 by x into x square by 4. So that x and that x cancels out. We are having x cube divided by 4 dx. And if you solve this further, over here you will be having 1 by 4 ln of 1. So that's basically 0. ln 1 is 0. Minus x by 4, that is 1 by 2 to the power of 4, 0.5 to the power of 4 divided by 4 ln of half. Okay, that's the thing that we are having from the first part. Then we are having minus integration of this. I can take 1 by 4 out as a common factor. And then this becomes x power of 4. X cube's integration is x power of 4 by 4. And the limits are from half to 1. And if I keep on solving it ahead, this will be, what is 0.5 to the power of 4 divided by 4. So that's coming out to be 1 by 64. So minus 1 by 64. ln of half can be written as ln of 2 to the power of negative 1, or else you can just keep it ln of half if you want. And then over here, if you solve it for this, so 1 by 4 into 1 by 4 is 1 by 16. I've kept minus out as common. And then we are having minus of 1 by 4 into x power of 4 by 4, which is nothing but 1 by 64. So what is 1 by 4 into 1 by 64? That comes out to be 1 by 256. Now if you solve this, so what is 1 by 16 minus 1 by 256? That comes out to be 15 over 256. So, but don't forget that there is also a negative sign. Over here also there is a negative sign. So it becomes minus 1 by 64 ln of half minus 15 over 256. Now also make sure that because we are in the lower part of the x-axis, like below the x-axis, right? The curve is below the x-axis. So the answer of the area will be the negative of this, because we need to get rid of that negative factor, because areas cannot be negative. Therefore, the final answer that we'll be getting for this is shaded area equals to ln of half. This is not 12, this is ln of half. So 1 by 64 ln of half plus 15 by 256. So what did we do in part B? Because we knew that for getting the shaded area, we need to do integration of the curve. So we are performing the integration over here. And now because it's in the format of UV, we can use integration by parts. And then by implementing those rules, we keep on continuing the integration like we did in AS level, following that same exact method, and then substituting the limits to get the final answer as this. So that's the end of part B. And I guess, yeah, there is no part C. So we are done with question 8 as well.